Welcome. In this video, we're going to look at the end-to-end process of submitting a workload to YellowDog to run on provisioned compute. What you're looking at right now is a work requirement that I submitted using our Python client. We also have Java and .NET clients available. Now, I've paused it briefly, held it, so that we can take a look under the bonnet. Now, this work requirement is made up of just two groups of tasks here because it's quite a simple workload. We're performing a set of individual image processes and combining them into a final single image montage. For more complex workloads, you might want to use multiple groups of tasks that should be run in different ways. So the key thing for a task group is the run specification. We can see here information about this task group such that it will retry failed tasks up to 3 times. And if a task still fails after that, the whole task group will immediately fail and stop running task. That's the finish if any task failed setting here. That's useful when, as in this case, all the tasks have to succeed in order to get the final output. You've also got your priority and any worker tags. So I'm only running this workload on workers that have this tag here listed on them. Now, if we open up the actual tasks themselves, you'll see that they open in a sidebar here that lets you see the task details without moving away from the main work requirement. Here you can check all sorts of things like the inputs and the outputs. That's the objects that need to be there before processing and the objects that need to be collected after processing is done. You'll notice this verification column here. You can use that to ask YellowDog to check whether the inputs are present in object storage before it runs the task. In this case, you can see the check mark here. That means that YellowDog has found that object and decided the task could go ahead and run. So in cases where some of your tasks are uploading outputs to be used for other tasks, verification also gives you a way to order tasks within a single task group. Now let's go ahead and actually run these tasks. Each individual task is run by a worker process. So let's have a look at the worker information which you can find here. So here's the node that's run that worker process. Each node is an instance that has an image installed on it with the YellowDog agent, so that YellowDog can manage that node and the workers that run tasks on it. Each worker is part of a pool of workers that have been supplied together, either as part of a group of on-premise instances or all provisioned by a single compute requirement. So let's go and have a look at that pool. So from here, you can see information such as that pool's worker tags. You can see that the workers have this tag here that matches the tag that was set on the workload. You can also see here in the properties section that this pool is set to automatically shut down individual nodes as soon as they're no longer being used. This means that we only use this compute for exactly as long as we need it. That's actually why this pool is currently empty, because it shut down all of its nodes while the work requirement was paused. But it will be starting some up again now that they're needed again. So this worker pool is supplied with instances by a compute requirement, and again we can see information about the underlying compute here. So this tells me that the request for the compute was made by an application, and how many instances it's asked for, which it's provisioning from these providers and instances. Now, this particular compute requirement was created using a template that sets a lot of these details. See, template. So let's look a bit more closely at the general requirements that I set in that template. So this is the template. And you can see here that it's a static template, which means that I specified exactly which sources I want YellowDog to use for provisioning. It's also possible to set up a dynamic template that allows YellowDog to choose the best sources to provision with based on criteria that you specify. This icon up here is also very important. This is the provisioning strategy, which in this case is waterfall, meaning that YellowDog will try to provision all the instances I've asked for from the first source listed, but if it can't, it'll fall back to the next source, and so on, which in this case means that a requirement based on this template will try to get its instances in the first instance from spot sources, but if it can't, it will move on to these on-demand sources that I've specified. Another key thing is the images ID. So let's just look that up by searching for the ID up here in the search bar. That will bring up, well, as you see, what it's brought up here isn't an individual image, but an image family, which works like a top-level folder. Within the YellowDog image registry service, an image family contains lots of different versions of this image, such as the latest version here, which contains all these different images, which are all compatible with different providers and regions. So what this means is that when I'm using the YellowDog image registry, I don't have to provide an individual image ID when I'm provisioning. I can just provide the path or ID of this overall family and let the YellowDog compute service look up the correct image that's required to provision each individual instance. Let's go back to the workload now. So as you can see, all of our tasks are now completed, and what that means is that they've uploaded all of their outputs. So they will have done that using YellowDog's object store service, which allows us to integrate with the object stores of the cloud providers that we support. So let's go and have a look at that now. So if we go to Objects and find the namespace, now you can see we've got here the original montage image that was originally uploaded as input. All of the task outputs are in their task group folders here, so we can click through to the final combined montage image that was output. And here we go. Now, all of these files are actually in the AWS object store, but we're currently accessing that absolutely transparently from right here in YellowDog. We've also got this task output file here, which can be used to give some logging as to what's happened as this individual's task has progressed. Now, obviously, we've also got full logging of the workload, which you can access from this logs page here. You can set the log level to include all the messages, or just ones that might indicate an issue, and you can also set, where has it gone? You can also set live logs to update the feed as new logging comes in. So for example, here you can see the scheduler service terminating the last node, and if we waited long enough we'd also see the compute service terminating the computer provisioned in an orderly fashion. You might also find it interesting to see how much compute has actually been used while these tasks have been executed, and you can get that from the usage menu down here. Now this allows you to examine your usage across different time frames, namespaces and so on, right down to individual workloads. So once again, going back to the workload itself, which I'm just going to stop now. That was a very quick run through of what goes on with running a workload and provisioned instances via YellowDog. So we ran our workload on workers, which you can get to from each individual task via this link here. These workers were supplied by a worker pool, which was provisioned using a compute requirement. We saw how the YellowDog image service can install the appropriate images on different instances. We saw how to handle input and output files using the object store service. And we also had a very quick look at some supporting tools such as logs and usage. Thank you very much for watching.